Today, Rory, Ellie, Caitlin, and I are going to be talking about vertisols. Vertisols are generally set in the areas of the world with dry seasons along with variable rainfall. They are common in places such as India, Australia, Sudan, and China. In the US, they are locally common to San Luis Obispo and Texas. Vertisols can be located anywhere but are characterized by their parent materials. Vertisols form on gentle slopes rather than rolling hills or steep slopes. This is because of the ability of the water to infiltrate the soil on gentle slopes, whereas in rain it would just run off the soils on steep slopes. Now we're going to talk about the main characteristics and features of a vertisol.
The main characteristics of vertisols is their shrink and swell capacity, which creates large cracks. They have greater than 30% clay throughout the soil. Presence of slick and slides is a good indicator that your soil is a vertisol. Vertisols have very few distinct, well-developed soils. Slick and slides form when clay minerals swell and cause beds to slide past each other. The large cracks are formed during the drying season in which the soil dehydrates and shrinks. However, the slick and slides form in the wetting season when the clay hydrates. This hydration of the clay causes pressure to build up and ultimately causes the beds to slide. Their colors range from red to gray to a deep black. When the soil is a darker color, it is due to the presence of organic matter and manganese oxides. Vertisols also have gill-guide topography, which consists of small hills and dips in a landscape created by the shrinking and swelling of clay. Another subsurface feature of vertisols are diapirs, which form when material is pushed up through the surface of the horizons. We're now going to discuss the formation processes of vertisols.
For the formation processes, vertisols' parent materials include some sedimentary rock, mafic igneous rocks, and volcanic ash. The shrink and swell nature helps mix the soil material, which is also known as argillopedoturnation. The older model, the self-swallowing model, involves the shrink and swell, which forms the cracks of a vertisol, which allows new surface material to fall further into the soil, as depicted by this lovely image with the squirrel kicking surface soil into the crack. When the rain season comes, the soil then expands, closing the cracks and ultimately mixing the new material into the soil. When the soil dries out, it contracts again and the cracks come back. This process is continually repeated. However, this first model is not as accurate because the carbon content is not distributed uniformly throughout the profile. There is another formation process, the soil mechanics model, where pressure from the top as well as pressure from the sides created by the expanding clays causes shearing. Next up, we have the uses and effects of vertisols.
Vertisols are usually formed under grasslands. They are good for animal grazing to an extent because animals can get injured due to the large cracks in vertisols. They have a high clay content and low permeability, which makes it suitable for crops that require water retention, such as rice. On the other hand, they are not good for commercial use and can be quite destructive. Their expanding and contracting of clay can be so strong and uneven that it damages infrastructure, and they can be quite a headache for engineers, as you can see in the pictures above. That's all, folks. Thanks for learning about vertisols.